Hello, in this lesson we're going to be talking about distance and midpoint of segments. And we're going to start by finding the distance for this segment here. I have one endpoint at 1, -1, and the other endpoint is at 2, 3. Now, one method we could use in order to find the distance here is to create a right triangle. So from 1, -1, I've drawn a horizontal segment over, and then I'm going to draw a vertical line up from there. And I've created a right triangle. Now, the base of this right triangle has a length of 1 unit, and the height of this triangle has a length of 1, 2, 3, 4 units. And knowing the Pythagorean theorem, that helps us find the hypotenuse, which would be the length of that segment. So we can do 1 squared plus 4 squared is equal to our distance squared. 1 squared is 1, 4 squared is 16, so our distance, or d squared, is equal to 1 plus 16. We have 17 equals d squared, so the distance must be the square root of 17. So let's talk a little bit more about how we got the side lengths of 1 and 4. Notice that, and I'll redraw the triangle here so it's not as in the way. We have 1, -1 and 2, 3. So how did we find this length right here? Well, if I go from an x-coordinate of 1 to an x-coordinate of 2, I've just gone over 1 unit. I did 2 minus 1 to get there. Going up, I went from a y-coordinate of -1 up to a y-coordinate of 3. And so from -1 to 3, it's a length of 4, right? 3 minus -1. And that's how we found those lengths. So a bit more of a challenge problem. How do we find this distance? Well, once again, I'll just draw in my right triangle. So I'll do my horizontal and my vertical to create my right angle, my right triangle. And we want to find this length, that distance right there of that black segment, the hypotenuse. So this piece right here, what is its length? Well, it has an x-coordinate of x sub 2, and this has an x-coordinate of x sub 1. x2 has to be bigger since it's to the right, so we could do x2 minus x1. Nice and sloppy. Going up and down, right, we have a y-coordinate on top of y2, y-coordinate on bottom of y1 to the height of y1. And so its length, well, y2 has to be bigger, right? It's on top, so we can do y2 minus y1. And so we set up the Pythagorean theorem. We have our x2 minus x1 squared plus, then our vertical piece is y2 minus y1 quantity squared, and that's equal to whatever our distance is squared. And then of course, to get our distance by itself, we square root both sides, and so we get the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So this right here that I've circled, this is the distance formula. Over the course of your geometry, I'm assuming you used it quite a bit. Please get it into your notes now. It is something you will want to basically have memorized. But remember that the distance formula is just a version of the Pythagorean theorem. So, anytime you need to find the distance, if you don't remember the distance formula, the Pythagorean theorem is an option. All right, let's move on to midpoint. Here we have two different segments. I have two different number lines and I have two different segments on them. In my first segment, I'm at -7 and it's going to 3. We want to find the midpoint of that. So going from 7 to 6, going from 3 to 2, 6 to 5, 2 to 1. Just keep going in until they meet. And look where they meet, right here at -2. So the midpoint must be at -2. And that's halfway between. And we can test this. From -7 to -2, that's a length of 5. From -2 up to 3, that's a length of 5. Okay, so indeed -2 is directly in the middle. How else could we have found that to be -2? Well, if we did -7 plus 3 and cut it in half. Really, if I add two numbers together and divide by how many I have, I'm finding the average. Or if I have just two numbers and I want to find the middle or median, I still do the average. Either way, and we end up with, of course, -2. Now I can do the same process over here for my vertical number line. -2 goes to -1, 5 goes to 4. We go into 0. That goes to 1. And uh-oh, we don't have a middle, right? So we must be directly in between 1 and 2, which gives us a midpoint of 1.5 or 3/2. Either way. And again, we can do the same thing. We can find the average. If I did 5 plus -2 and cut it in half, that gets me 3 on top, 2 on bottom. And notice that this length from here up to here is 1, 2, 3.5 units. This length here is 1, 2, 3.5 units. So let's put this together on a coordinate plane. On this coordinate plane, I use the exact same numbers that I had before. Notice my well, I'll start with left, right. My left, right goes from -7 over to 3. And so its midpoint should still be, here it is at 2. And if I go the up-down, I went from -2 up to 5, and its midpoint should still be 1.5 or 3/2, right there. And so the midpoint of this segment should be at, well, that -2 over and 1.5 up, roughly there. So the midpoint should be -2, 3/2. Well, how can we find that easily instead of having to draw it? Let's say I was just given, oh, I have two coordinates, and again, I'll use x1, y1, and x2, y2. So how do we find the midpoint? Well, we determined on the previous slide we could just do the average. I'll take my x's and add them together and divide by how many I have. I'll do the same thing with the y's. I'll add them together and divide by how many I have. And this right here is the midpoint formula. Another formula to get into your notes, write down. We will be using it later on. Okay, we are done.